Hey, so this is going to be for chapter 6.4. Just a quick update. I've got most of your guys' tests. They are getting graded. I'm grading them. I'm hoping to have all scores into PowerSchool of turned in test by Wednesday or Thursday. Okay? If you would like them back, please email me and I will set up a time for you to pick them up, or I'll take pictures and send them to you. It's up to you however you want to. If you want them back, great. If you don't, it's up to you. I think I said that like 3 times now. Sorry. Also, I want to let you know that I have posted the review assignments for the final. These are not required. They are in Unified Classroom under class pages. The tab that is assignment notes and answer keys. There is like a bingo type review and then an actual worksheet review. Personally, I think I would start with the bingo, and then if I have sections that I struggle with, then I'd go to the worksheet and then pick the specific sections that I need additional help with. I'm hoping that we can do some sort of like Google Hangouts or something prior to the final. You can ask as many questions as you need before the final. I'll have more information coming towards the end of the week or on Monday. So yeah, here we go. 6.4. Okay, so with 6.4, we are going to be doing vectors and dot products. Okay. With multiplication of vectors, there's technically 2 types. One of them is a dot product and the other is a cross product. So there's 2 ways to multiply vectors: dot product, cross product. In our class we focus on dot products. If you were in a physics class, you would definitely be focused a little bit more on cross products. So cross products happen quite often in physics. We're going to focus on dot products. Okay, so the idea of a dot product is basically if you were to have, let's say, a vector here, a vector here, let's call this vector A, a vector B. What's going to happen is, what it is, a scalar describes the product of 2 magnitudes. And I ran off, but magnitudes. Okay, and it's a scalar, meaning it's just going to be a single number that talks about the size. Okay. So it's not just simply the 2 magnitudes multiplied together. It's the part of vector A that has let's see, the kind of like same direction as vector B. Okay. So not projection, but same direction magnitude as vector B. So with a dot product, it's kind of describing if I were to combine these 2 vectors into the same direction, what would their magnitude be? So it's I like to think about it as if I had a flashlight right above my, this is a flashlight, okay, right above my vectors, and I click it on, and it projects, I don't know, it lights up this area, and it would cast a shadow, and straight down it would form this 90-degree angle, this right triangle. And if I look at this, say this is theta, and And I want to see, like, if I was to take vector A, its direction and magnitude, and I want to see how much of it is in the same direction of B, I would need to find this adjacent side. So we know this would be the magnitude of A. And if I want to find this, so it's like taking this and projecting it onto vector B, it would be cosine, right? Adjacent over hypotenuse. So this right here, oops, that would be my phone awkwardly going off, would tell me that cosine of this theta would be the adjacent over the hypotenuse. And if I multiply that, I'd get the hypotenuse times cosine theta equals the adjacent. Well, we know the hypotenuse, like we said, is the magnitude of A times cosine theta is going to equal this adjacent piece. Okay, so this adjacent piece right here is the projection of A onto B. So when we have that projection, really the direction kind of loses its significance. Oh my goodness, sorry. That is just so awkward. Okay. Yeah, awkward. So basically, vector A dot product of vector B is the product of the magnitudes of A and that part of B which have the same direction. Okay, I know it's a little weird. It sounds complicated, but it's not too bad. Just keep in mind, it's not simply multiplying the magnitudes together. It's the idea of multiplying them, their force direction together. It's kind of like if you looked at this picture, how if you are both pushing in the same direction, you're going to have a lot more force. You're going to have a better result than if they're against each other. So a dot product is going to tell us how to take these two opposing vectors, or these two vectors that are in the same direction, or as close to the same direction as we can, and figure out their scalar, their combined magnitude. Okay? So, let's look at this. Sorry, well, apparently I'm a little confuffled. Okay, so if we look at this, we have this vector B. So really the dot product, let's say, of vector A dot product vector B, that's going to give me the magnitude of vector B or A, this order doesn't matter, times the vector of A cosine theta. Okay, this is one of the formulas. This is we're going to use when we are finding the angle. Okay, so I use this one if I'm looking for theta, if I want to find this angle. Okay, but I know these two, this and the two magnitudes. Okay, the one that we use a lot though, if we're not finding the angle, is vector U dot product vector V equals U1 V1 plus U2 V2. Okay, so this one we use when finding the angle. This one is our basic dot product. If honestly guys, if this whole thing confused you, I would look at a few videos. It's actually kind of interesting. As I said, in physics we do a lot with it, but for now we're just in this situation just looking at the general, what it is and how it works. So I actually want to do a few. We're going to find vector u dot product of vector v. Okay, so let's say vector u is 5, 1, so in component form, and vector v is 3, 1, negative 1. Okay, so if I did a dot product of those two, that's going to be 5 times 3 plus 1 times negative 1. So that would give me 15 minus 1. So that is simply a dot product of 14, meaning their combined magnitudes basically in the same direction would be 14. Okay, let's do another one. If I had vector u is negative 1, 3, and v is, and I'm going to run out, is 2, negative 4, the dot product of those two would be negative 1 times 2 plus 3 times negative 4, so that'd be negative 2 minus 12, which is negative 14. Okay, when we get a negative result, basically that means those two are fighting against each other. So they're working against each other, going in opposite directions. So if you look at this, negative 1, 3, 2, negative 4. Okay, these two are opposing each other. They're going in opposite direction. So their combined force, because of this opposite direction, they're not really working together. They're working against each other. Okay, so anytime you get a dot product that's negative, it just means they're working against each other, going in opposite directions. Okay, so force in the same direction is the magnitude. It's the result of the dot product. Okay, let's do one more. I think I have space right here for one more. So let's do u is 2i plus minus 3j, and v is 6i plus 4j. And if you remember, that just means that my first vector is 2, negative 3, and my second one is 6, 4. Remember, that's just the linear form versus the component form. So sorry, I did not space this. So we'd have u dot v would give me 2 times 6 plus negative 3 times 4. So that would give me 12 minus 12 is 0. Okay, so they're kind of canceling each other out. Their combined force is 0. And if you were to draw those, what happens is they actually create a 9-degree angle. So so if you think about it with a shadow, it wouldn't cast a shadow at all upon the other one. Okay, so if you actually drew this one out, let's see. If you drew this one out, I know it's crooked, but you would have your 2, and if you cast a shadow, it wouldn't actually force it on top of the other one. Anyway, kind of interesting. So that is our first part of finding a dot product. In the next video, we'll do a little bit more on finding the angle in between, and then talking about perpendicular, parallel, or neither. Okay, so next video.